Good evening, everyone. I'm glad to share these few minutes with you to close the topic number 4, operations scheduling. We are closing this important chapter, so I would like to make some remarks about the topics that we cover and give you some tips about what's the future of scheduling in your career. Give you some ideas what you could expect in this field. But before I close the chapter, I would like to mention something about the collaborative assignment. In fact, I received many questions. I'm showing you problem number 2. So as you can see, something different that you found in this problem is the last sentence in the problem. It says, it is now the beginning of time 5. It looks, this created some problems for some of you, how to interpret this sentence, that right now it's the beginning of time 5. As you can see in the table, we have the day each job arrived. For example, the first job arrived at time 0. The second job arrived at time 4 or day 4. So we could think about a timeline. So right now it's the beginning of day 5, and for example the first job arrived at day 0, so that implies that it arrived 5 days ago. If we assume that the jobs arrived at the beginning of each of the specified days, then we know what are the days since the jobs arrived. So I prepare this second table that I'm going to show you, where we have the date each job arrived, and then we have the next column is the time since the job arrived. So we are at the beginning of day 5, and the first job arrived at the beginning of day 0. So 5 minus 0 is 5. So the first job arrived since 5 days ago. So if you have this column, the time since the job arrived, then you can easily compute the finish time for each job, assuming that you start again at the beginning of job 5. So the only difference with this problem is, first, you need to compute this, or well, the easiest way to solve the problem is to compute these times since each job arrived, and then you begin your process analysis at day 5, because right now we are at the beginning of day 5. So the starting time, the starting day to process job 1 is day 5. It takes to process the job 7 days. So you have all the day 5, 6, 7, 8, 9, 10, 11. At the end of day 11, you finish job 1. In the same way, you start job 2 at the beginning of day 12, and so on. So I hope this tip could help you with your collaborative assignment. Let's continue with the topic. So this chapter is operations scheduling. So what do we schedule? Well, we can schedule jobs, we can schedule employees, we can schedule services. So this tool is useful not just in the manufacturing area, it's also very useful, and it's highly applied in the service sector, because almost in everyday activities we need to schedule resources. The common example is the airline industry, where we see a lot of scheduling issues. So it's a good example. We have, as I mentioned you, employees, jobs, like the problems that you were solving, workstations. So it's something very useful. And here we have a Gantt chart. You were creating Gantt charts for the problem where you use um, the Johnson's algorithm. You were asked to develop some Gantt charts. In this case, we have the Gantt chart for a operating room. But see, you can identify some idle time in that Gantt chart. As you know, the objective of the scheduling techniques is to minimize the completion time, to minimize the cost, to minimize that idle times, to maximize utilization. So we could have different objectives. In fact, the problems that we have solved in this chapter are easy problems. Usually in real cases we don't face this kind of easy problems. In real cases usually we are trying to combine different objectives. So what we do is a multi-objective optimization. So this first approach or this first way to study scheduling problems, well, it's a good introduction to know the basic methods that you or we could use. But of course, there are more complex algorithms. There are more complex methodologies to solve more complex problems. So we mentioned in this chapter these sequencing rules. So we mentioned the first come first serve rule, the earliest due date, and the shortest processing time. So in the first one we schedule the jobs as they arrive to the workstation. So the first job in arrive is the first job to be scheduled. In the second one we schedule jobs according to the due date. So the job with the shortest or the closest due date is scheduled first. And in the third one, in the shortest processing time, as the name suggests, we schedule first the jobs with the shortest processing time. So as you remember in the problems, the processing times is known information, known data. And in this case we use two types of performance measures, the float time. In fact, we computed the average float time and the average past due. In this case, we wanted to minimize the float time. We wanted to the average float time. We wanted to minimize the average past due or the make span. The make span is the total completion time. So we wanted to minimize the make span. But as I mentioned, the objectives could be others. In fact, in real scheduling problems, for example, a term that we should include, that we should consider, has its cost. So we are interested to minimize the cost to obtain the best schedule, and the best one, of course, implies the minimum cost. Also, we solve the problems for two parallel machines, two sequential machines, and we review the Johnson's algorithm to solve this problem. After the sequencing rules, we studied another important topic, that is the line balancing. So in line balancing, we check how to compute the minimum, the theoretical minimum number of machines, the smallest theoretical number of machines or workstations but we are using that theoretical minimum because sometimes when we create the groups of machines, when we create the workstations with several machines, sometimes we cannot reach that minimum number. For that reason, in this technique we use that concept, the minimum theoretical number. It could be that number or a bigger one. Not necessarily we will be able to achieve that number. So we have an example. I will show you one example. You have another examples posted on Blackboard, where we can see the groups that we define using the, well, I cannot find my example, but we create groups, we create workstations and manufacturing cells with a specific number of machines, and again, not necessarily that includes the, or it's going to be equal to the minimum number that we get with the formula. So this topic, scheduling, is highly relevant because, as I mentioned, so in everyday activities we need to define schedules. In manufacturing organizations, of course, it's something that we need to do every day. In fact, we create a production plan, so this is a function of the demand that we know from the customers. We verify capacity, we create our MRP, and then we define with all this information the schedule. And in some industries we do this every day, in other industries we have to do that in a weekly basis. So it depends the type of industry, the needs are going to be different. And this is something very common, very popular in the pharmaceutical industry. But think about this. So we are producing a specific drug in a pharmaceutical industry, and then we need to change to another drug. So I'm mentioning this example because in this case it's very common that we need to do a setup. So a setup is prepare the equipment, prepare the machines, prepare the resources to receive a new product, and that also consumes time. And this is also part of the multi-objective optimization problem that I told you. In this case also we want to minimize the number of setups, we want to minimize the time required for setups. In fact, the order in which we use the machines matters. So it's not the same to produce drug A and then drug B and then drug C than the opposite, because maybe the setups could imply a higher effort when we have a specific order. So think about that. Scheduling is a very complex problem, bigger than we solve in this chapter, a lot bigger, with multi-objectives. And this is a very good example where still we have plenty of opportunities for doing research. Many researchers develop algorithms to solve these complex problems. In my particular case, I have worked with some colleagues solving problems for the pharmaceutical industry, and this is what, for that reason I'm mentioning you this example, because it's something that I know very, very close. So it's a very big issue, and if you are able to develop a good algorithm, you can generate huge savings for the company. So I encourage you to go deeper with these topics. They are very useful. We apply them every day. So it's very important for your professional career to be proficient in solving scheduling problems. If you are interested to know more, don't hesitate to contact me. I will be very happy to. I'll be glad to provide you further references to study these topics deeper. So I would like to finish this session showing you my contact information again. So if you have any question, don't hesitate to contact me. I'll be glad to answer your questions. And I hope you are enjoying this class. This is wonderful techniques that you will use in your professional life. So study very hard them. They are very handy to solve everyday problems. So have a very nice day, and I'll be happy to answer any questions. See you soon again.